Hey, what's up, Math 8? This is Mr. Bainey, and we're going to review a little bit of Module 7 to help prepare you for your test. So what I'd like you to do is go to page 223 if you don't have it already out, and we're going to take a look at the first three problems. So number 1, 2, and 3, if you could please pause this for about 5 minutes, and then after those 5 minutes, you'll see the solutions for 1, 2, and 3. If you need to do this on a separate piece of paper, then go ahead and do that because they don't give you a whole lot of space here. So you're going to see me sort of doing some work outside of this page. Okay, go ahead and pause it 5 minutes. And here are the solutions for number 1 and number 2. As you can see in number 1, I wrote the equations that I ended up with in red. The blue is what I did to both sides. And I subtracted 1a on both sides first to make this a 0. That's a 0 there. Then I got 3a minus 4 equals 8. I wanted to make a 0 with that minus 4. So I added 4. And then at the end, I wanted to make a 1 by dividing by 3. So I got a by itself equals 4. And then number 2, subtracted 1x on both sides to make that a 0. And then I subtracted 5 on both sides to make that a 0. Then I got my 1. Okay, sorry that was a little quick. Go ahead and pause it if you need to copy that. Take a look at number 3. Hugh is arranging chairs. She can form 6 rows of a given length with 3 chairs left over, or 8 rows of the same length if she gets 11 more chairs. So that's going to make a big difference how you do the 3 chairs left over and then getting 11 more chairs. So this is the equation I came up with. Right down here at 6c plus 3, that's the 6 rows. C is how many chairs are in each row. And then the 3 is how much is left over. The 8 is the 8 rows times the number of chairs in each row. And we need 11 more chairs, so we're 11 chairs short. So I subtracted. And then once I solve that, I do get C equals 7. So there's 7 chairs in each row. Okay, and with that, again, go ahead and pause it if you need to um, copy any of this or make any corrections to what you have. And once that is done, we're going to go ahead and go to the next portion, 7.2. Looks like you're going to be doing numbers 4, 5, and 6. And go ahead and pause this for about 5 minutes while you try out number 4, 5, and 6. And here you see the solutions for 4, 5, and 6. I'll briefly go through them. Number 4, if it's fractions, we want to try to get rid of the fractions to make the equation a little bit nicer. So what we want to do is find the LCD, and the LCD is 6. Remember, you're going to look at the denominators, 3, 3, 6, and 3, and you want to find the least common multiple. So that is 6. If you use something like 12 or 18, it should still work out the same. Okay, 6 being multiplied through with everything is going to give us this equation, 4n minus 4 equals n plus 8. Then I go through and I do the exact same steps that I did with the first couple problems up here, and I get n equals 4. Okay, for number 5, with decimals, some of you choose to leave the decimals and just work with it from there, and that's totally fine. The method or the process that we used in our notes is to multiply everything by either 10, 100, or 1,000 to move the decimal point over however many times. One common mistake, though, is that some people do some multiply some of it by 10 and some of it by 100 and forget to multiply the rest. So in here, we're going to multiply everything by 100. So this 1.5, you got to move it over twice because it's 100, and we get 150. 3.25 becomes 325. 1 times 100 gives us 100. And 2.25 times that 100 gives us 225 with a D. Then from there, we go through and we solve it. These are pretty big numbers. You'll get that with these decimal problems or decimal equations. So use a calculator if you need to. And lastly, number 6. I did not show my work just like with number 3, but here's the equation that I got. $19 plus $1.50 per hour. Per hour means for every hour it's $1.50. And then the other place, Wolf Watchers, is $14 here, plus $2.75 per hour. So we want them to be equal to each other. And then I did not show my work, but I went through and solved it and got 4 hours. Okay, and we're going to go ahead and move on. Pause it if you need to right now before I move this out of the way. We're going to go on to the next section. In fact, let's go ahead and do both 7.3 and 7.4 at the same time. So take about 5 minutes. Let's move this. And you're going to be doing all of 7, 8, 9, and 10. I'm going to put all those solutions in the next part or in the next about 15 seconds or so. So go ahead and pause it. Again, about 5 minutes while you try out 7, 8, 9, and 10. And here are the answers to number 7 and number 8. Now, number 7 is actually a pretty challenging one. I don't think you'll see anything like that on the quiz or on the test, but it is something that's good to know. I'm talking about the distributing the fraction and multiplying it inside. So I don't think you'll have any questions on the test where you're distributing a fraction. Okay, but as you can see, here are the steps. First, I distributed that fraction and got 1/4 x minus 7/4. And then the right side stayed the same because there's no parentheses. Then I multiplied everything by the LCD, which is 4, and kept going. So the rest of it, as you can see in a lot of these problems, starting it out is probably the toughest part, but finishing up is usually the exact same process. You know, getting zeros on both sides and then making that one at the very end. On number 8, you have to do distributive property on both sides. So you can see my lines going from the 3, multiplying inside, and then from the 2, also multiplying it inside. I get 3x plus 15 equals 6x plus 24, and then I go through and, again, do the same process. So I get x equals -3 for that one. Okay, go ahead and pause it now if you need some time to copy this. And now let's take a look at the answers for 9 and 10. So I actually did it right here on the page. It was still a little cramped, but I managed to fit all of it. But I need to talk about kind of where my thinking was. So for number 9, actually number 9 and number 10 are very, very similar in that the left side where we do distributive property is exactly the same. The right side was the part that's a little bit different over here. So when I distributed, I got 5x minus 15, then plus 6 equals 5x minus 9. So I copied that part. The minus 15 plus 6, or you can think of it as negative 15 plus 6, does give me minus 9. So when I get to the next step, 5x minus 9 on the left side, and I also have 5x minus 9 on the right side, I can stop right here. If you want to subtract 5x on both sides to make those 0, you do get -9 equals -9. And when both sides are the same like that, that means that we can plug in any x value, anything as an answer at this point. So therefore, we have infinite solutions, infinite number of solutions. On number 10, now same process here. I started down here, and then I got 5x minus 9 equals 5x minus 10. I made my 0 with 5x, subtracted it on both sides, and then I got -9 equals -10. Now, because this is a false statement, right, -9 does not equal -10, I have 0 solutions. I put no solutions, but it's the same as saying there are 0 solutions. Okay, and that's going to do it for the review for this. I hope that this was sufficient practice for you, and I hope you do well on the test. Good luck. Have a good day.